In my recent issues, we talked about the largest and most famous moons of the Hansen Jupiter. You, friends, can easily find them on my channel. And today we will continue to explore the surroundings and the fat man of Jupiter, and talk about the rest of the lesser known, but no less interesting moons of this planet. We will find out which are the fastest satellites, what are reverse rotating satellites, and why some of them were assigned the letter E at the end of the name. Everything in this release. For convenience, scientists have divided the moons of Jupiter into several groups. So we use this idea in groups and go through. Most of Jupiter's moons are relatively small compared to their counterparts. They are icy or rocky objects of irregular shape. All satellites of this small group do not have the mass and fluidity of composition to stretch themselves into the normal spherical shape that we are used to seeing. Among the surface features, they have impact craters, hills and valleys. The largest satellite of this group, Amalthea. This is about the fifth moon in size. The distance to the planet is 181,400 kilometers. It takes Amalthea about half an earthly day to complete one revolution around its master. Amalthea is notable for the fact that it is the reddest object in the solar system, and according to the assumptions of scientists, it emits more heat than it receives from the sun. This may be because, since it rotates in the powerful magnetic field of Jupiter, an electric current is present in the core of the satellite. Amalthea is a highly cratered satellite. The craters on it are quite impressive in size. For example, the largest crater Pan is about 90 kilometers in diameter, and its depth is at least 8 kilometers. There is also a crater, it is 75 kilometers in diameter and at least 10 to 20 kilometers deep. As far as we know, all Amalthea craters have a simple bowl-shaped shape, without a central hill. The reasons for this are low gravity on the satellite. The close distance from Jupiter suggests that being even closer, the satellite will simply be torn to pieces. However, because the moon is very small, it is relatively immune to tidal forces. Since Amalthea is very close to her planet, her orbit will eventually be disrupted and she will fall to the planet. Well, quite a sad fate, but the same fate, by the way, can befall another moon from the group of small satellites Metis. This object is interesting in that it revolves around Jupiter faster than Jupiter itself revolves around its axis. Metis and another satellite of Adrastea, the satellites closest to Jupiter. The distance to the gas planet is 128,000 kilometers. These crumbs of 20 and 40 kilometers, respectively, are also the fastest satellites, real sprinters just. In order to make one revolution around the planet, they only need some 7 hours, almost a working day on our Earth, and the next group is even more interesting. Reverse rotation satellites are located here. Like this. Quite a reasonable question. Such satellites move towards all other satellites of Jupiter, and the position of the orbit is slightly tilted in relation to their planet, the distance from Jupiter, and this feature give every reason to believe that in the past these are ordinary asteroids caught in the gravitational pull of Jupiter. To somehow highlight them, scientists marked the letter E at the end of their names. Sinope, Carm, Ananke, and Pasiphae. Add the Himalaya group here, too. All have similar orbits and appearance, so they are considered to have a common origin. The smallest moon in this group is Leda. Its radius is about 10 kilometers. Well, the largest is Himalaya, with the radius of 160 kilometers. This also includes Licata and Delara. I suppose that all these satellites were once one, the largest asteroid, which forcibly pulled the powerful Jupiter into its arms, splitting it into pieces along the way. But compared to other groups of Jupiter's satellites, there is much less confidence that all the satellites in the Pasiphae group arose after one collision. This is primarily due to differences in color, ranging from red to gray, and differences in tilt between the satellites of the Pasiphae group. In particular, it is suspected that Sinope began its existence as an independent asteroid. On July 17, 2018, a group of scientists led by Scott Shepherd of the Carnegie Institution announced the discovery of 12 new moons of Jupiter. Such an unusual find was made by chance, since the main task of astronomers was to search for a hypothetical ninth planet, far beyond Pluto's orbit. The first time the satellites were noticed, back in the spring of 2017, with the help of a 4-meter telescope named after Victor Blanco, in Chile. Among the 12 satellites, one object was described as special, and the remaining 11 were ordinary. A special moon, named Vela Judo. According to Scott Shepard, this is a real eccentric, as it has an orbit unlike any other moon of Jupiter. He crosses the orbits of the outer group of 9 moons and, accordingly, may be the troublemaker that destroyed them in different periods of time, but he himself naturally suffered. So Vela Judo is the smallest discovered satellite of the giant planet, with a diameter of less than 1 kilometer, and it is possible that its former mass is already part of these 9 retrograde moons of Jupiter. And finally, if Metis and Adrastea are the fastest, then the satellite S2003J2 can be safely called the slowest. The fact is that being on average at a distance of about 28.3 million kilometers from Jupiter, the satellite needs about 1,077 Earth days to complete one revolution in orbit. Our 3 years, you can imagine. Well, to watch the new issue you don't need to wait 3 years, I think a few days at most. On this, by the way, we complete our flights around Jupiter and go to Mars. Don't miss Phobos and Deimos, very soon in the heading of interesting satellites. Like it, subscribe to my channel. All good mood and see you soon.